Welcome. I think we left off with an example that I let you finish on your own, right? Or at least kind of get started on. And so what I'm going to do is just pick right up. So from last day, we were working on this problem. Let's see here. I'm going to grab this one, copy. And we had done a little bit of work already, so I'll grab that as well. Copy. And then we'll fill it in together. All right. So just as a reminder, right, let's just read through the question real quick here. So Okie Dokie Finance Company advanced 3 loans to D, $2,200 on June 23rd, and there's no year. So what we said was, let's just pick a year, 2022, that's fine. In most questions, you'll be given a year, so then you'll need to be able to work with that. And first, let me just mute everyone here. There. That's better. All right. So no year, so we just pick a year, whatever your favorite year is, that's great. And then so 1,800 on August 5th and 1,300 on October 31st. Simple interest at 7.25%. Now here I will make a note that this is the simple interest chapter. And so we're quickly going to move away from simple interest because, as I mentioned, it's very uncommon that we have simple interest. Usually we have what's called compound interest, but this is where we learn the skills that we need and then we just build on it. Okay, so simple interest is where you are earning interest for some amount of time and then it's tacked on at the end, and then that's the total value after some period. Okay, so that's something to keep an eye out for, not in this chapter because it's the only thing that we're dealing with, but later when we start talking about compound interest, right, then you need to decide, okay, is this a simple interest problem or a compound interest problem, right? And so that's why I'm pointing it out now. 7.25% was charged on all 3 loans. So it could also be that you have a different interest rate on each of the loans. So in this case, no, because we're just starting out, right? We're just growing, right? But that could happen, okay? And all were repaid on December 31st when some bonds that she owned matured. What total amount was required to pay off the loan? So what we did kind of step by step was, well, we picked a year. Then what we did was we drew a timeline, okay? And on that timeline, you're going to have little I call them ticks or notches or whatever you want to call them, little kind of time points for any date that's mentioned in the problem. Okay, and that's going to take some practice, right? Reading the problem and figuring out where to put these notches, how many to put in. Notice that I didn't spend any time trying to make them kind of proportional. No, I just split the timeline into quarters or thirds, I guess. Right, with 4 time points. Then what we did was we put the dollar amounts, okay, under each of the dates, so each of the corresponding dates, because what has to happen is, for example, this $2,200 she has to pay interest on from June 23rd to December 31st. So how we show that is with this arrow, okay? And the only reason that I have the October 31st amount as the future value 1 instead of future value 3 is just because it's how it appeared. And also I don't want to have to draw arrows above each other. It makes it really messy. So usually when I draw my arrows, I start at the closest value and then I move out. Okay. So let's see here. Let's call this, because I called this future value 1, future value 2, and future value 3. just as a reminder, the future value is the amount that's owing on December 31st. Okay, so if you add all those up, then that's going to be the total amount required to pay off the loan. So that's the amount that we're looking for. Okay? But there's quite a bit of work to get there. First thing I'm going to do is I'm going to call this times subscript 1. Okay, because it's going to be in there for some number of days, right? And we know how to find the days between dates from last day, right? We learned a lot last day. I'm going to call this time 2, and I'm just matching the subscripts. Otherwise, it would get really confusing. Okay, and then this is going to be time 3. So what I'm going to do is I'm going to find time 1. Okay. Time 1 is going to be the days between dates. October 31st, 2022, let's say, and December 31st, 2022. Okay. So I'm going to use the days between dates calculator. Okay. And just remember that the days between dates calculator requires month, month, day, day, year, year. Notice the decimal here, month, month, dot, day, day, year, year. So we're going to have date 1, date 2, and the days between dates, which is what I'm solving for, so I add a little asterisk. Okay. Date 1 is October 31st. Okay. October 31st, the month is 10, the day is 31, and the year is 2022. Okay. Date 2 is December 31st, so 12.31.22. Okay. What I'm going to do is I'm going to set up all these calculations, because that way I don't need to be going back and forth to the calculator. However you want to do it is totally fine by me. But what I'm going to do is just side by side here, I'm going to find time 2 and also time 3. Okay. Same thing, date 1, date 2, and the days between dates. Oops. Which again is what I'm solving for. Date 1, date 2, days between, dates. Yeah. What's really nice here is that date 2 doesn't change, right? So you don't need to re-enter it every time. You can just go flip back and forth and change date 1 and then go back to days between dates and calculate it. Okay. August 5th. August is 08, 05/22, 12.31/22. I'll put those in right away here, right? Because that doesn't change. Date 2 is always the same. June 23rd is 06/23/22. Now let's see here. If I can do that. Hey, not bad. Cute. All right. So I'm just tickled pink. All right. So, and no ads too. It just keeps getting better. To get to the days between dates calculator, you have to use the date function, which is a second function. So you have to hit second date, and it'll show up with date 1. Now I'm just going to work through these. So date 1 is going to be 10.31/22. Remember, it doesn't store it until you hit enter, right? So enter. Now it has that equal sign and it's adjusted it to the proper date format. Right, so that happens quite often, is that you forget to hit enter, right? And then you move away and then it goes back to whatever it was before. Date 2, this is the one that's going to stay the same, 12.31/22. So you want to make sure that it's right. Enter. Okay. And now I'm going to scroll down, right? And I'm using these up and down arrows to move between the lines here, days between dates. This is not the value, right? That's the value from last day. What I have to do to compute the days between dates is hit that CPT button in the top left-hand corner. Compute, it's 61 days, so it only changed slightly. 61. All right, on to the next one. I don't need to leave the screen or anything like that. I can just scroll up, change date 1, scroll back down, compute the days between dates. So it's relatively quick here. Okay, date 1 is the one I want to change to 08.0522, enter. And then I'm going to scroll down and compute 148 days. You always want to check in and make sure that what you're saying makes sense, right? Time 1, so 61 is the shortest, and then time 2 should be the middle, right? 148 is longer than 61 days, so that makes sense, right? Otherwise, it'll make a complete mess. All right, for the last one, we're going to scroll up to date 1 again, 06.2322, enter. Scroll down, 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 days between dates, compute, 191. Nice. Now I'll just show you how to, oh, not with the ad. I'll just show you how to leave the dates, days between dates function. You're going to hit second compute, which is the quit function. So second quit, and that just puts you back into regular calculator mode. So now I'm going to put this, put this down. Dink. All right. So now these are days, right? And we said there are 365 days in a year. And so time 1 is going to be 61 over 365. Okay. We use 365 even if it's a leap year or anything like that. And so we just use 365. It's close enough. Time 2 is 148 days out of 365. Remember, time is always in years. And time 3 is 191 over 365. All right. In order to have all the information that I want on this kind of timeline here, I'm also going to jot down that the rate was 7.25%. Okay. And so the rate, and it just kind of goes somewhere here, is 0.0725. Okay. What we can do, just to emphasize, is, and I don't usually do this, but this is our first kind of big timeline that we're doing. And so what I'm going to do is I'm going to jot down that the values on the timeline are present values, right, or principal amounts. So I'm going to call this P3, right, just matching those subscripts, P2 and P1. Okay, now we have all the components in order to calculate these future values. Let's grab that formula sheet here. So for simple interest, we have these to choose from. And that's where it's helpful to recognize that, okay, the question said it was simple interest. So now I'm focused in this section of the formula sheet. Okay. We're going to use this formula here because it's a future value that I want. Okay, we haven't introduced this formula, but as you can tell, there are different rates and different time points for each rate. And so that's when we have changing interest rates, which we do not have. Okay, and so this is the one that we want. So we have, let's just write it down. The future value is P times 1 plus R times T. Just checking to see if we have all the components that we need to solve for each of the future values. I have a P for each of them. I have an R for each of them. It's the same 0.0725. And I have the time for each of them. So now I'm ready to solve for these future values. So future value 1 is P1 times 1 plus R times T1. R stays the same for all of them, so I'm not going to use a subscript there, but I can solve for future value 1, P1. And this is where it's so important that you just keep the values that belong together, right? Using the same subscript. It doesn't matter if you use 1, 2, 3, A, B, C, or whatever, right? Just make sure that they're the same. The principal amount that she borrowed was 1,300 times 1 plus, and the rate that she has to pay it back at, right? The interest rate, because she has to pay it back with interest, right? We know that. That's like in every movie there ever was. Yeah, but you'll have to pay me back with interest. Maybe not every movie, but a lot of movies. So we know that. And it was borrowed for 61 days. And so 61 out of 365. Okay. Now I'm going to, oh, not that one. I'm going to use this calculator because we have the luxury of using kind of a nicer calculator than the financial calculator. So that's what I'm going to do. You're going to have to be really, really careful with your order of operations and using brackets properly. Okay. And so I'm going to map this one out as you would do it incrementally. So 61 over 365. First thing you're going to do, find that value. Okay. Then you're going to multiply it. So I'm going to do that on the next line. Notice how I can use that answer button. So the previous answer. And I'm going to multiply that by 0.0725. Okay. Now, right, I have that answer. So I'm going to do 1 plus the previous answer. Okay. And then I'm going to multiply it by 1,300 times that previous answer. And oh, you know what? I'm not quite done. Delete. Because now what I want to do is just show you how to do it properly in one line. Okay. And so I'm going to start just as it's written, just making sure that you keep the brackets in there, and we should arrive at the same answer because the calculator knows the order of operations. 1,300. When we use brackets, it knows that it's multiplying. Bracket 1 plus, that's just how clever it is. Oops, sorry. 1 plus 0.0725 times 61 over 365. Now you have to step it up. So if I just hit the bracket here, it puts the bracket down low, which is wrong, right? Those brackets need to be outside, and it even helps you with finishing your brackets. If you've worked in any sort of programming language, like, I don't know, in math we use Maple, or MATLAB or in stats we use R, right? Then you know how important it is that you close those brackets, right? Otherwise it's a complete mess. So this is what I wanted to show here. So now I'll bring this in here. Insert. Don't need this. But I do want this. So these are the proper steps. Okay. Or this is just in one line. Notice that we get to the same answer. Okay. And so here, the future value 1 is 1315, rounded to 2 decimal places, right? Because it's money, we have 75 cents. And that's from here. Okay. So let's see here. Future value 2. Future value 2 is the principal amount for loan number 2, which was, I can't remember, 0.0725 times, oops, sorry. I forgot. I was writing out just the general equation. I'm being super thorough with my work here for this one because I'm sure this is one that you're going to refer back to when you're working through these problems. So I don't want to skip any steps. Later on, I get lazy and I start kind of just jumping right in and maybe not writing the subscripts, that kind of thing. Okay. The principal amount for loan number 2 was 1,800 and it was borrowed for 148 days. There. I'm going to skip straight to the answer. 1,852.92. Future value 3 is principal amount 3 times 1 plus R times T3. And I have it here. It was $2,200, I think, for 191 days. Times 1 plus 0.0725 times 191 over 365. And that becomes 2,283.46. Yeah. Looking at this, it's technically first loan, but future value 3, right? She borrowed $2,200. She has to pay back $2,283.46. Meaning what? Meaning she has had to pay, or she will have had to pay $83.46 in interest, right? But the future value is the principal amount plus the amount of interest. Okay. So it's not something that I recommend that you do, right? I want you to use the future value formula, but another thing that you could have done, right? If you prefer to use this formula, I is the amount of interest, what could you do? You could have used this formula to find the amount of interest, 2280, 283.46, $83.46 for that first one. Okay, and then added it to P, right? But that's what this formula is doing, and we derived that last day. And so I wouldn't recommend doing that. I recommend just using this formula, but just remember that that's the makeup of the future value, right? It's the principal amount that you borrowed or put in the bank, invested, right? Plus the interest, right? That you're either getting or giving. Okay, if you borrowed money, you have to give it back. Okay. So then the total owing, right? The total amount that she would have to pay on December 31st is future value 1 plus future value 2 plus future value 3. We already mapped that out, right? So this becomes $1,315.75 plus $1,852.92 plus $2,283.46, which means that she would have to pay $5,452.13. Yeah. What was the original amount? Notice she borrowed $2,200 plus $1,800 plus $1,300. Just do that quickly here on the side. Plus 1,800 plus 1,300. So she borrowed $5,300. How much is she over some period of time, right? So the total amount that she borrowed so that she had to use was $5,300. But then how much interest did she pay? Oops. Interest paid is $5,452.13 minus $5,300. And to keep it all on one page, 54, 52, 13, $152.13 in interest, right? So those are all things that we could be asking questions about, right? So it's good to have a really good handle on how these things are made up, right? But there's a principal amount and then you pay interest on it, and then that makes your future value. Okay. So like we've seen, so that's kind of the review from last day. Keep it all on that page, or finishing from last day rather. So now that we've seen a timeline, let's just break down the components of the timeline, because they're going to be so useful for mapping out your questions. Now, you guys are working online, and so you don't need to show me a timeline, although it is something that I give marks for in a written test. Okay, and so but the only reason I do that is because they're so useful for mapping out the problem. So I really, really encourage you to start making timelines, because it's going to help you organize all the information. Okay? And so in terms of timelines, we use timelines to organize information. To organize information. I guess organize information, we have been given and to plan our calculations, right? That's how we used the timeline earlier, right? We had, okay, so we had the days, we had the dollar, the loan amounts, and then we mapped it out, and then we were able to visualize what we had to solve for and how we could get there, right? We saw that, okay, I need to find each of these future values. Okay. So I'll call it the general anatomy of a timeline. Okay. And they can become quite complicated, but in general, like this is how they are all built. Okay. And so you can build them up and you can have different things in here, but the general anatomy of a timeline is like this. Okay. You're going to start with your timeline. You have a start and an end point. Okay. So here we have a start date, and here we have an end date. We've already seen something more complicated than this, right? Where we had multiple time points. Okay, but each of those are just tiny timelines put together, right? And so we have a start date and an end date, and any dates in between go on the timeline. Okay. Below here, we put some dollar amount. Okay. Or what it will be worth at the end date, right? So sometimes we move the other way where I have, okay, you invest some amount of money and in the end you have $2,283.13. Hopefully that's the number we had earlier, right? How much did you borrow 191 days earlier, right? 2,200, because I'm just taking it backwards. Right? But so we could be given this future value and have to solve for the present value. Okay. In general, right, we have some P and some future value. Okay. I'm just going to write PV, present value, because that's what we're going to call it once we get into compound interest. And so I'm going to start to get you used to seeing that PV, Puerto Vallarta, no, or just P if you prefer. And what we do is we draw an arrow to show that, okay, I invested some present value, so some principal amount, and now I want to solve for the future value, or I have some future value. How much is that worth today? Okay. So solve for the future value or solve for the present value. Okay. And usually we have the time on the arrow. Okay. Yeah. I know whenever I say PV, I always think Puerto Vallarta. Yeah. I can't help it. It's where we would all rather be. All right. So, and then the last part here that we're going to jot down, just kind of totally, just kind of anywhere on here, if you have different rates, right? So maybe you have a one rate for one timeline, one rate for another one, then I would put it on the line. But just in general, you would write the rate somewhere around here, right? And so the rate is something. Okay. So how about this? I call them LFFs, little fun facts. Now I don't have to explain what LFFs are, little fun facts anymore. I'll have more little fun facts, but fact number 1 is that we draw the arrow in the direction that we're moving the money. So the arrow points in the direction the money is moving. The next fact is that the present value is always on the left and the future values are always on the right, okay? Because it is a timeline, so it is moving chronologically. And so we have some present value turning into some future value, right? After you either accumulate interest or start owing interest, right? And so just always present values are always on the left and future values are always on the right. Yeah. I mentioned that because that trips a lot of people up. How do I know where to put the future value? How do I know where to put the present value? Right. And so just remember that it is a timeline. So it is working chronologically. So you always start with the present value and end up with a future value. Even if the information that you have is a future value, right, you can map it back and figure out what it's worth today. And we're going to see examples of that. Let's see here. The third one, in order to have a complete timeline, right, you need to have all the components for using that formula, that future value formula in there somewhere, right? And so that's why we just put the R down somewhere. Okay, so to have a complete timeline, all the components of the future value is P times 1 plus R times T, kind of a big space here. Let me move that over there. And so all those components must be accounted for on the timeline. Accounted for on the timeline. Okay. With the exception of the value that you're solving for, right? You only have to solve for one of these things, right? The value that you're solving for, you'll just leave it as a variable. Okay, so just as the letter. Okay. The value you want to solve for is left as a variable. Okay. The fourth thing is that each tick on the timeline represents a date of interest. Okay. And so as you read a problem, what you're going to do is you're going to just make a note. So usually somewhere on the side, just kind of in my rough work or somewhere on the side, I just start making a list of the dates that I have. Okay, so all the dates that I've been given, they're not always in chronological order, so I might need to rearrange them. Okay, and so so that's why I jot down each of the dates that I have to work with, right? And then I put them on a timeline. That also helps me figure out how many ticks I need, right? And so that's kind of the hardest part of getting started, I think, is figuring out how many ticks do I need and what are those dates, and then everything just kind of flows from there. Okay, but so each tick on the timeline represents a date of interest. So what you want to do, right, is make or kind of here, I'll jot down, I'll say what I do. Okay, so as you read a problem, okay, so as you read a problem, jot down, so just quick scrap work, right? Make a list of all the dates mentioned. Make a list of any dates mentioned. Put them in chronological order. Then draw a timeline with the same number of ticks. Draw a timeline with the same number of ticks. Okay. This isn't quite a fact, but each tick will typically, so not always, sometimes we have a reference point, like I took out a loan 2 weeks ago, and I added it to a loan that I took out 2 months ago, right? How much do I owe if I'm going to pay it back in 3 months, right? So there's no dollar amount today, but I do have one from 2 weeks ago, 2 months ago, and then I'm going to pay it back. So I like to have that reference point on my timeline, even though there's no dollar amount at that point, right? We'll see an example, so don't worry at some point. Okay, so the fifth one is each tick will typically have some arrow, right, going from or to it. Each tick will typically have an arrow going from or to it. Okay. Let's see here. Did we finish all these? We did. Okay. Let's do this one. Oh, maybe I don't have it. Okay, we're not quite ready for that one. Where? I thought I had it. We've already solved that one. Okay. Let's see here. Of course, it's in part 3. Sorry, guys, I don't have, let me just go find it. Just give me a second here. This was an oversight. I thought it was on one of these lists, but it was not. I want example 145, and it is so close here. All right. Put it in there and also into our notes, and I'll post these, repost it. Okay. 145. Judith, no H, received the proceeds from an inheritance on March 25th. Again, no year, so let's use 2022 just for fun. She wants to set aside enough on March 26th so that she will have $20,000 available on October 1st to purchase a car when the new models are introduced. If the current interest rate on 181 to 270 day term deposits is 3.75, so 3.75%, what amount should she place in the term deposit? Okay, so what we want to do is just map out all the dates, and then there's a decoy date in here, right? The March 25th. Nothing happens, but let's just put it on the timeline, right? And so as I read this, okay, I'm just going to start to underline and just make a note here. March 25th, March 26th. Okay. And October 1st. Okay. Okay, and those are all the dates that are mentioned, right? They're not always dates, but often they are, right, for these problems. Okay. What we're going to assume, we will assume the year was just last year, okay, 2022. All right, so this March 25th, I can put it on there, but nothing happened. Okay, so what we want to do is just to practice, I draw a start date and an end date. And what I'm going to do is I'm also going to put a tick for March 26th. I'm going to put them relatively close because there's just one day between them, but also the first one is nothing happened, right? But so these were already in order, right? Because remember, make a list of any dates mentioned. So that's what we did. Put them in chronological order. That's done. Okay, and then draw a timeline with the same number of ticks. So that's what we're about to do. Then we're going to put the dates on top here. So March 25th, March 26th, and October 1st. So this one's different from what we did before, right? And so here, she wants to have $20,000 available on October 1st. Okay. So what we want to do is we want to find, okay, so here, she needs to have $20,000. Okay. And we're going to force that to become $20,000. What we want to know is she wants to set aside enough on March 26th. Okay. So that $20,000 has to grow to $20,000 from March 26th. So now, in terms of moving our money, like I mentioned, right, the arrow is going to take that 20,000 and move it to March 26th. Right? All we know is that 20,000 is worth less than 20,000 on March 26th, but we don't know how much, right? So here, right, this is going to be, I'll call it the PV or P. Okay. This here is a decoy date, right? There's nothing happened here. She got her inheritance, and then the next day she went to the bank and deposited it. And so that's why that becomes the present value, right? But what we want to do is we want to move this $20,000 back to March 26th. Yeah. So let's see here. We need to know what the time is. And date 1. So the date 1, even though the arrow is moving from October 1st to March 26th, date 1 is still March 26th, right? And so date 1 is going to be 03/26/22, and date 2 is going to be October is 10/01/22. So the days between dates, let's find that out.
Turn your low energy into big fitness energy.
All right, guys. There. Okay. So I can calculate the days between dates. Second date. Date 1 is 03/26/22. Enter. We should be pretty comfortable with the days between dates calculator right now, or by now, right? If you're not, then definitely work through these problems that we've done already and just kind of force yourself to become comfortable with it, because you're going to be using it. Okay. Date 2 is 10/01/22. Enter. The days between dates compute. What happened? Oh, 2020. Okay, that's bad. 10/01/22. Enter. Now days between dates, 189. It was the negative dates that I did not like. So 189. Second quit there. So 189/365. Another thing, right? We need to have the rate somewhere on here. So I'll just write down that the rate, I'll just put it on this arrow here, is one hint, right? Is that, okay, well, the days between dates has to be somewhere between 181 and 270. Right, 189, so we're good, right? And so because there's no other rates given, 0.0375. Okay. So now, right, PV or P, and this, let's see here, what color can I use? This is the future value, right? Guess I could have used the same color. Anyways. The future value is P times 1 plus R times T. So now I have 20,000 as my future value. I'm trying to solve for P times 1 plus 0.0375 times 189/365. Oh my gosh. I wanted like this. Whoa. Why does it look like this? Sorry. I don't know if you can see. It's all smudged. Hopefully it'll sort itself out. I'll do the calculation. Okay. So what you can do is you can solve for everything in the brackets, right? Making sure you use your brackets properly, and then divide that over by the 20,000. Okay, and so let's see here. I want 189 divided by 365. That times 0.0375. 1 plus that. And then I want 20,000. 1, 2, 3, 4. Divided by the previous answer. Now let's see if I can bring that in here. Come on. Just not going away. All right. Phew. Looks so weird. I think it's when I kind of split the screen. Crop. Let's see here. Bigger. Okay. So P rounded to 2 decimal places should be 19,619 and 4 pennies from here. Okay. Which makes sense. You always want to check in and just kind of ask yourself if your answers make sense, right? If you had accidentally treated the present value as a future value, what would happen? Your present value would be more than 20,000, which doesn't make sense, right? Then you would be paying interest to have it invested. It doesn't work like that. So at 3.75%, right, she would have to invest $19,619.04 in order to have 20,000 by October 1st, which was the goal. Right? And so that is the time value of money, right? Is that you only need to invest $19,619.04 in order to have $20,000 in 189 days. At a rate of 3.75%. Okay. And so, so now, right, we've used a timeline to solve for the future value. We started there because that's what the formula is laid out to solve for, but we've also solved for the present value. Okay. So far, we have solved for the future value, which is P times 1 plus R times T, and P, which if you rewrite it is the future value divided by 1 plus R times T. So now in this next section, what we want to do is we're going to solve for R and T. Now we did just briefly derive the formulas last day. So, but I'm going to rederive them because it can be a little bit tricky, right? And so we'll work through them. But so 4.5, section 4.5, should I put it on the first page? Sure. Why not? Is on the rate of interest and the term of investments. R and T. Right, so really here, solving for R and T is what we're about to do now. Okay. Okay. So like we said, from the future value equals P times 1 plus R times T, if I want to solve for R, for example, and the same thing goes for R, or for T rather, I have to start with the future value divided by P is 1 plus R times T. To solve for R, I need to get R times T on its own, which means I have to subtract 1 from both sides. So minus 1 is R times T. So to solve for R, what I need to do is I need to divide by T from both sides. So I get the future value over P minus 1 divided by T, oops, is R, right? And the future value divided by P minus 1 divided by R is T, right? So from here, I can solve for either one, right? Because they're being multiplied together, they're going to be the same, right? So from here, oops. And you know what I'm realizing is I should maybe move these to the center here. So from here, I can solve for R, or I can solve for T, right? Or rewriting them, R is the future value over P minus 1 divided by T, and T is the future value over P minus 1 over R. And these are not on your formula sheet, but it might be nice if you just jot them down and have them on your personal formula sheet, right? Because you are working open books, so there's no reason why you would have to derive this every time. I will, just for practicing kind of math, right? But if you want to just use these, you go right ahead. Okay, so here, these are not on the formula sheet. But might be nice to, but might be nice to have. Okay. Kind of a weird smiley there. So just have them somewhere written down, right? If you add to that formula sheet or however you want to do it, that's totally fine. Okay. I had something, but I think I'm going to skip that one. Let's just go straight to an example. Oops. Down here. Bump it to the top. So I don't have to scroll around so much. Let's see here. Thinking. Okay. I'm still going to use a timeline for this. It's very rare now that I won't use a timeline, even for very simple problems, right? One, to get used to drawing timelines, but also just to get in the habit of always doing a timeline, right? Even for simple problems. Okay. You invested $5,500 1 year ago. Okay. Today, it has grown to a total value of $5,733.75. What rate of simple interest did you have for this investment? Okay. So now we want to solve for R. And maybe here. So in terms of our timeline, right, I have 1 year ago and then today. Okay, so I have 1 year ago and today. So my timeline, very basic, looks like this. 1 year ago and today. Okay, so in terms of the dollar amounts, so the dates go up top and then below the ticks, we put the dollar amounts. In this case, we have dollar amounts under both of them, and that's totally fine because we're solving for R. So you invested $5,500, which grew. So now I'm moving that money. It might be it could be. Sometimes it's a little, he gets ahead of himself sometimes before he introduces the problem. I'll have to have a look, but it could be. It kind of seems like it, example 148, but could be. But we are solving for R, so I put it in this section. Okay. Okie dokie. It grew to $5,733.75. Yeah. The time is relatively simple, right? It was 1 year ago to today. And so then we know that the time here is just 1 year, right? So remember, time is always in years. And so 1 is really easy. And we want to solve for the rate. Okay. So let's say here we have, this is P and this is the future value. I have both of those values, right? But they're still denoted by variables in our formula. So you can jump right in from here, right? Solving for R, that's totally fine. You have all the components, you have the future value, you have the principal amount, you have 1. And then you have T is a 1, right? And so it's relatively simple, but what I want to do is I just want to use the 1 formula for everything. Okay. So, but I'll show both calculations side by side. So from here, right, the future value is P times 1 plus R times T. So 5,733.75 is 5,500 times 1 plus R, which I'm solving for, times T, which is 1. Okay. So then I get 5,733.75 divided by 5,500 is 1 plus R. To be left with just R here, I have to subtract 1 from both sides. I'm gonna swing it around so I have R on the left like I like it. But then 5,733.75 divided by 5,500 minus 1 is, oh, and I don't have a cheat sheet here. Oh, it's not. Keep doing that. Clear, clear all. Okay. 5,733.75 divided by 5,500. And then to do it in one line, it's really important that you step outside of the fraction and do -1. Okay. And so the rate then 0.0425. Okay. Let's see here. Or you only have to use one of these, right? But I want to show you that either one works as long as you're applying your math properly. And this was written huge. Point there. Or using this formula, right? R is the future value over P minus 1 divided by T. FV over P minus 1 over T. R is 5,733.75 divided by 5,500 minus 1 divided by 1. Which is also going to be so finicky there. So now I can do 5,733.75 divided by 5,500, step out, close the bracket, minus 1. And then divided by 1, if we want to do that, is the answer. Divided by 1 is also 0.0425. So here, this came from this, and this came from this. But obviously, they're all the same. Okay, so it doesn't matter which way you use, just be careful. So then what was the rate of simple interest? 4.25%, right? So therefore, the rate of simple interest was 4.25%. Remembering that as soon as we're dealing with the rate, right? The rate we usually report as a percentage, but in math, we have to use the decimal version or the proportion. Okay, nice. We're ready for another example. I have, okay. Sorry, I'm just looking at let's do this example 155. And then I have a pretty fun, well, fun for me, maybe. Okay. Oh yeah, I love this one. Mostly because my parents have neighbors across the street that they socialize with, and their name is Wayne and Janice. And so it's very close to Janet. And I just think that this question is so absurd. So anyways, just kind of funny. So Janet borrowed $15,000 from the Bank of Wayne on November 5th, 2001. It was a different time for a new necklace. Very important. The Bank of Wayne charges 7.45 simple interest, so 7.45% simple interest. Interest accumulated, okay, amounted to $1,534.67. On what date was the loan repaid? Okay, so now, in order to figure out the date that the loan was repaid, what am I going to have to do? I'm going to have to solve for t, right? Because that's going to be my gateway. Okay, so we'll need to solve for t, right, in order to answer this. So first thing I'm going to do is just map out the problem. Okay, and so let's see here. I have November 5th, okay, and after some amount of time, we know the amount of interest that she paid on it, but we don't know how long, right? But it's still at some point, right? So I can still draw that endpoint. So in terms of my timeline, it's, again, a relatively simple timeline. And date 1 is November 5th, 2001. And the end date is what we want to find. Okay. So kind of a weird question because we haven't seen something like this before, right? But just like solving for R, as long as you have all your components on your timeline, then everything will just kind of start to fall into place. Okay. All right. So you can use the amount of interest formula. I'm not going to. I'm going to use the future value and the fact that the future value is the principal plus the amount of interest. Okay. And so just to make a note here, I is the amount of interest, remember, right? And so the interest accumulated amounted to $1,534.67. The principal amount was $15,000. Okay. We have the rate. Oh, what color have I not used? Let's use purple. Rate is 0.0745. Okay. Okay. In terms of our dollar amounts, right? Here, most importantly, the future value is P plus I, which is going to be 15,000 plus 1,534.67. I'll just do it here sneakily. 15,000 plus 1,534.67, which is 16534.67. Okay. So in terms of the dollar amounts, 15,000 that she borrowed turned into, so it's going to be going this way. Now she owes 16,534.67. Okay. So the principal amount plus interest is the future value. Okay. I'm trying to solve for t here, right? And somewhere on this, let's put it on the arrow, 0.0745. Okay. Looks like I have all my components that I need in order to solve for t. And again, just these first two problems where we solve for r and solve for t, I am going to do them side by side. But in future kind of calculations, I'll just start from the future value formula. For me, it makes more sense to only have to remember one formula, not multiples. But it depends on how comfortable with manipulating equations you are. So let's see here. The future value is the present value times 1 plus r times t. So the future value is 16,534.67. The principal amount was 15,000 times 1 plus 0.0745 times t, which we're trying to solve for. Rearranging this, I get 16,534.67 divided by 15,000 is 1 plus 0.0745 times t. So I get 16,534.67 divided by 15,000 minus 1 is 0.0745 times t. Swinging that around, I get 16,534.67 over 15,000 minus 1 divided by 0.0745. That is the equation that we had for the t, right? So that's why I say you don't really need to have it, but it might be nice to have. So, or t is the future value over p minus 1 divided by r. So now t, if I just plug these values in, 16,534.67 divided by 15,000 minus 1 divided by 0.0745. Doesn't matter. The calculation stays the same. So I'm going to clear this. And as long as I use my brackets very carefully, right, then I'm okay. I anticipate needing brackets around the entire numerator. And so what I'm going to do is kind of, I hit a space bar. Hopefully that doesn't do anything weird. Okay. What I'm going to do is I'm going to jot down just brackets around here, right? Just to keep that all in the numerator. Okay, bracket. 16,534.67 divided by 15,000. Step out that bracket, minus 1, close that bracket, divided by the rate 0.0745. So here, doesn't matter how we got there. T is 1.373306488. Right. One problem is that 0.3733 years doesn't mean anything to us, right? And so what's the next thing that we have to do is we have to convert 0.3733 into probably days is going to be the closest thing. Okay? And so what I'm going to do is, right, we need to, and maybe we'll do the whole thing. We need to convert this into days, right? The reason I'm gravitating towards days is one, it's more precise than months, for example, but also I have a precise date, right? I have November 5th, 2021, or sorry, 2001. Quite a difference. And so to use the days between dates calculator, I need to know the number of days between these two dates. Okay, so that's why we need to convert this into days. How can I do that? Multiply by 365. So answer times 365. Oops. So, okay, so here's where it gets a little bit tricky. Okay, so it is 501 days, 0.256868 days. Okay, even though when we round, right, typically when we're rounding, this would round down to 501 days. But at 501 days, the loan isn't quite paid off. Okay, and so that means that, okay, then on day 502, it'll be paid off. Okay, so here, right, we're gonna need she will need 502 days to pay off the loan completely. One thing to note is that if you're doing Moodle problems with these calculations, if you're rounding properly, just like I'm teaching you now, right, and it's not working, try using the unrounded value. It's not proper, but sometimes I find that the coding behind the scenes is kind of it's not proper, and so sometimes if you don't round, it'll give you the right answer. But in this case, it'll be fine because we're going to use the days between dates calculator. Okay. So 502 days. Wait. So now we can use date 1, date 2, which is what I'm solving for. Oh, my software update. It's like not, I don't want to do that now. Oops, and the days between dates is 502. Date 1 was what? November 5th, 2001. November 5th is 11/05/01. So now
Turn your low energy into big
there. Okay. Date 1. So I need my days between dates calculator, of course. Second date function. Date 1 is 11/05/01. Enter. Make sure it's 2001, right? Just so it doesn't do anything weird. And then I'm going to skip date 2. So I'm going to scroll through, fix the days between dates to be 502, right? I think this might be the first time that we're doing this together, right? But we said, as long as we have 2 of the 3 components, we can solve for the third one, which we do. So now I'm going to use the same method and I'm going to force this 502, enter. Now I'm going to go to date 2 and compute. It even says that it was a Saturday. Cute. It was Saturday, March 22nd, 2003, which happens to be my dad's birthday, March 22nd. So it was Saturday, 3/22/2003. Cute. Gonna quit that. Oops, quit. Janet repaid the loan on March 22nd, 2003. On a sunny Saturday, she decides, all right, I'm going to pay this off with interest. All right. Nice. Now, let me just go flip around here. Okay. Sure. Okay. The next example that I want to do, I don't think I have it in here, so I'll have to add it in, 151. But I like it, so I'm going to keep it. Uh, 150, where is it? 151. Okay. And before I forget, put it in there, fix that up later. Here's where we get into the important stuff. Well, a trip to Vegas. All right. Andre and Shane can book their Vegas holiday package at the early booking price of $3,900 or wait 4 months and pay the full price of $3,995. Okay. Which option should they select if money can earn 5.25% rate of return? Okay. And then the second part is, at what simple interest rate would they be indifferent between the two? Okay, so there's 2 parts, and obviously we'll work through part 1 and then move into part 2. All right. So here, let's just underline the days that we have. So they can book an early booking price, and there aren't really any dates, but there are clues. Okay, so they can wait 4 months and then pay the full price. And so in terms of the time value of money here, so here we have 3,900 as a present value. They can pay that right away, or in 4 months they can pay $3,995. Okay. So what we can do is we can draw a timeline. So here, I'll just make it today for simplicity's sake, and then 4 months from today. We don't need to get any more specific than that. Yeah. It's also the time I'm going to put on my arrow, right? But let's see here. So what we want to do is $3,900. In theory, I could, or Andre and Shane, I guess, could go to the bank at 5.25%, invest $3,900 for 4 months, and then take it out and then pay for the trip. Right. So what we want to find out is, can they get more than $3,995 or less? right? And then depending on what happens there, we'll be able to make a decision. So what we want to do is we want to know, okay, $3,900 today is worth how much in 4 months? So T is 4 divided by 12, right? Because it's just 12 months in a year. So here, the future value is what we want to solve for. Okay. The rate is 0.0525. Okay. So this is for part 1. Okay. So what we want to know is this future value more or less than $3,995? Okay. Okay. So here, we want to know how this future value compares to 3,995 in order to make our decision. In order to make our decision. Okay. Okay. So let's see here. Future value is the principal amount times 1 plus R times T. So that's going to be 3,900 times 1 plus 0.0525 times 4 over 12. I'm just going to tell you that it is 3,968 and 25 pennies. Okay. So how do we make a decision here? Option number 1, 4 months from now, so paying the early booking 4 months from now, right, is worth $3,968.25, which is cheaper, right, than $3,995. So for that reason, I'm going to go with the early booking fee, right, or the early booking price. Okay. So here, and this is kind of the takeaway here. In 4 months, the early booking cost is $3,968.25, right? Basically what it's saying is you could have gone and invested it at the bank and you would have received $68.25 in interest, right? But that's not enough to cover the 95. Now, if that was higher, right, let's say it was an even 4,000, then it's slightly better to just go and invest it at the bank and then take that out and then pay the $3,995 and have $5 left over, right? And so a little bit tricky, but once you start kind of stepping back and thinking about it in terms of common sense stuff, then it comes together. And I say that, but that's not easy, right? And so in 4 months, the early booking cost is $3,968.25, which is less than $3,995. So we should buy the early booking option. Should buy the early booking option. Nice. Okay. So which option should they select if money can earn 5.25%? The early booking option is the cheaper option, relatively similar, but here we're pinching pennies. At what simple interest rate would they be indifferent between the two? Okay. So at what rate of interest would we need to have from the bank in order for, at the end, so in 4 months, $3,900 to be worth $3,995, right? Then it would be the same. Yeah? And so really what we want to know is, let's map it out, is from today and 4 months from today, 3,900 is going to grow to 3,995. Then we would be indifferent, right? Paying $3,900 today or $3,995 in 4 months from now, right? There is some interest rate where it doesn't matter. Those are the same, right? And so here, the time is still 4/12, and the rate is what we want to solve for. Okay. Remembering that this is the present value and this is the future value. In order for these guys to be indifferent. So the future value is P times 1 plus R times T. 3,995 is 3,900 times 1 plus R times 4/12. If I rearrange this, and I'm going to try to keep it on the same page, so then, and I might not be successful, but 3,995 divided by 3,900 minus 1 divided by 4/12. I'm not successful. Well, maybe. Okay. Keeping track of my brackets, 3,995 divided by 3,900. Close that first bracket, minus 1. End bracket for the numerator, divided by 4/12, which I'm going to put in brackets just so it doesn't get confused. And I get 0.073077, which will round, but how do I squeeze this onto one page? Because this is the last one that we're doing. So here, R is 7.31%, right? The rate of interest that was being offered at the time was 5.25%, right? In order for it not to matter which option you choose, right, then the interest rate would need to be 7.31%. So there are lots of different problems that we can solve just using the tools that we have. So we've solved for the future value, the principal amount, we've solved for the rate, we've solved for time. Okay? There are a couple of small little concepts that we add on, but we've seen the bulk of it. And so I'll post an example for simple interest for you to work on over reading break if you'd like. I'll make it due kind of towards the end of reading break. You can do it this week if you want. And then we'll pick up here after reading break, I guess. It feels weird to say because it's not until next week, but we don't meet until I guess 2 Mondays from now. If you have any questions, let me know. Otherwise, have a great break. And I hope you get everything done that you're hoping to.
Thank you, Prof.